Hello, this is Mr. McLeod, and I'm going to do a little demo on 2D array processing, basically looping through arrays and looking at the values and maybe returning a new array or perhaps printing out the information or whatever you need to do to process the 2D array, right? So this is with 2D arrays. I'm going to assume that you've already gone through the basics of 2D arrays, so you already know how to access items in 2D arrays, but you perhaps haven't looped through them and processed them with the for loops. So we're going to start with a simple example where we're just going to make a function that a method that prints a 2D array like a grid. So let's go to this one here. So print grid is going to take a 2D array and it's going to print that 2D array out in a grid. So to do that, we need to first figure out the number of rows and the number of columns in the 2D array so that when we do our general strategy, we can just say for each row and then for each column, right? So basically like a double for loop for each row, for each column, just print the value at that row column. And then we want to go to the next line, right? So we're gonna be printing. So for each row, we would print like 3, 2, 5, 4, 6, 5, and then we want to go to the next line, right? So then I'm going to write that down here in my plan. After we finish all the columns in a row, then we're going to say go to the next line, right? So if we implement this plan, this should work pretty good. So to do that, first we need to say how many rows there are going to be. So we can get that based on, in a 2D array, the items in the outer array, right? So the items in A are arrays, right? So that would mean the number of these arrays is how many rows there are, right? Because each of these arrays is a row. So for example, here there's 1, 2, 3, 4, 5, right? So if we simply say a dot length, the length of that array is going to be the number of rows. If we want the number of columns, we can make an assumption here because this is true 99% of the time, unless there's some special situation you have. You can assume that every row is the same length, right? So each of these arrays are each going to be the same length. So therefore, they're all going to be the same length as the first one. So a simple thing to do is just assume that the length of each of these is going to be the same. So we can say, go to the first one and dot length. Okay, so we're also making another assumption, which is that there is at least one row. And I think for the purpose of this problem here, we're going to go ahead and do that. Assume that there's at least one row in this 2D array. It would be fairly simple to add some extra checks if we wanted to make sure that there was at least one row. Heck, we could even check if A was null, but we're not going to worry about that for now. Okay, so we got the number of rows, number of columns, and then we can just do our little loop here. Let's see, I'm going to do it like this. So for each row is simply going to be, so for int row equals 0, row is less than the number of rows, row plus plus. Okay, so for each row, let's see, and then for the curly braces, I'm going to say this is the outer loop, so it's going to go right there. Okay, and then for each column, right? So for int call equals 0, call is less than num calls, call plus plus. Okay, so we go through all the columns from 0 to up to, but not including the number of calls, just like you would loop through an array, a 1D array. Okay, and then once we finish that row, right, once we finished all the columns in that row, then we go to the next line, right? Okay, so first let's deal with this one. So for each row call combination, we need to print the value at that row column, right? Yeah. So we can say system.out.print. Notice we're not doing print ln, right? We're doing just print. Okay, so that's because if we did print ln, it would print and then go to the next line. Okay, and then what we want to do is we want to print the item at row call, but then we also want a space. So we're going to say plus space. Okay, we could also do this in 2 lines. If we wanted to say, let's store the value first, right? We could say int val equals this value at a row call, and we press print that value. Okay, because since this is a 2D array of ints, each item in the 2D array is an int. Okay, and then once we've printed that, then we can say, okay, we've printed every value, and this is going to end with a space, but we're not going to worry about that for now. No one will see it, and I'm just not going to worry about it. So then to go to the next line, you can just say system.out.println. There we go. And that's it. If we hit run, this is going to see how it goes. There we go. The original array, you can see up here. These are all same values, just printed out in a nice grid pattern. Okay, actually, you can even see the extra space at the end of each line there. Okay. All right. So then now for the next problem, to get a little bit more complex. What would happen if we wanted to make a 2D array? If we wanted to take a 2D array, then do some processing, and while we're processing it, we're going to fill up another 2D array, and then we're going to return the new one. Okay, so in this one, we need to return a new 2D array where any values with either an odd row or odd column are going to be set to 0. And all the other values are going to be set to the same corresponding element in the original. Okay, so if we were to draw what this looks like, the rows, remember, would go 0, 1, 2, 3, 4. So that means all the odd rows, right? Like all the items in row 0, sorry, all the items in row 1 and all the items in row 3 are all going to get set to 0. And then also we got column 0, 1, 2, 3, 4, oops, and 5. It's a terrible 4. It's okay. And so then all the items in column 1 will get set to 0, right? And all the items in column 3 are going to get set to 0. And all the items in column 5 are going to get set to 0. So then in the end, you can see there are still going to be some values where both the row and column are both even, where we end up having the same value, but then all these other ones are all going to get set to 0, right? Okay, so hopefully you got an idea of how that works. So that's the plan. So to implement this, essentially, the beginning is going to be the same. We need to know how big the 2D array is. So we can just start with gathering that info. We got num rows and num columns, just like before. The num rows is going to be a dot length, and the num calls is going to be a 0 dot length. Again, we're going to assume there's at least one row. Okay, and then we can say, let's make a new 2D array. Okay, so int 2D array, we'll call it B, right? So we got array A and array B, and this is going to be a new int array. And then in each of these, we need to say how big this is going to be, right? So it's going to have the same num rows, and it's going to have the same number of columns, right, as the original. All right, so we've got our new 2D array, and then we just need to loop through for every row and for every column. So this part is going to be the same, right? So for every row, for every column, we need to decide what to fill in at that position in array B, right? So all we need to do is check to see if either the row or the column is odd. Either row or column is odd, then we set it to 0, right? Let's write our plan out like we did before here. So if either row or column is odd, set value at row column to 0. Okay, and then else, otherwise, right, which you guys know is going to be an else. Otherwise, set value at row column to original value at row column. Okay, so let's turn this into code. Okay, so if, and then for a value to be, or for a number to be odd, remember that means if we take that number mod 2, in other words, we divide by 2, then the remainder is going to be 1, right? So we can say if row mod 2 is 1, or if column mod 2 is 1, then we know either the row or the column is odd. Okay, then we're going to set the item in array B at row column is going to equal 0. Right, so we're setting that value to 0. Okay, otherwise, right, so else, we're going to set the value at row call to the original value at row call. So B at row call is going to equal A at row call. All right, so then at the very end here, we do have to make sure that we return B, right? So we are looping through A, and well, we're looping through all the indexes that are actually both the same size. So you decide, are we looping? I guess we're really looping through B, right? And deciding what to place at each index, right? Okay, and then sometimes we access items in A, other times we just set it to 0. All right, let's hit run. See what this looks like. Whoops, we forgot to actually comment this out. Okay, so it's just going to print the original. All right, so if we comment this, we uncomment this out, then it's going to print the original, and then it's going to print the 0 grid and actually call 0 odds and print it. Okay, let's try that. There we go. Okay, so you can see here for column 1, these are all zeros, right? Column 3, these are all zeros, and column 5, these are all zeros. And then for row 1, these are all zeros. And for row 3, these are all zeros, right? And then all the other values in there are whatever they were in the original, right? So we got the 3 here, right? We got the 5 here, and so forth, right? The 4, this 4 right here. Okay, so this looks good. All right, let's go to the next one. Okay, so the next one, I'm going to go ahead and actually uncomment that, and we're going to comment this one back out again. And we're going to do the next level where we're going to do a problem where we have to process an array, and sometimes we're going to be looking at the values, not just at the position that we're at, but also the values around it. And that's where we have to start worrying about things like out of bounds, right? So let's take a look at what the problem is here. We're going to return a new 2D array of the same size as the given 2D array, where each value is set to the sum of the values to the left and below the corresponding value in the original array. And this is where we deal with the out of bounds here. If the value to the left or below does not exist, then it counts as 0. All right, so let's take a look at a couple examples here. If we were going to fill in this position in the new array, we would look at the value below is 2, and the value to the left, which, because it doesn't exist, counts as 0, right? So then this would get filled in as a 2, right? If we were looking at, this one's a good one to look at. If we were looking at this one, the value to the left doesn't exist, and the value below doesn't exist. So the total is going to be 0, right? Whereas if we were in one of these ones in the middle here, like if we were looking at this one here, the value to the left is a 4, value below is 1, so this would be a 5. Okay, so hopefully that gives you an idea of what we're doing. So let's go ahead and do it. So ultimately, this is still going to involve getting the number of rows, the number of columns, and creating a new array of the same size. So we're going to just go ahead and put that in there straight from the previous problem, right? So we now have an array B that is the same size as A. And then it's also going to involve going through, and we could say we're looping through all the positions in B and deciding what to place there. Okay, so we could say for each row and for each column, we're going to figure out what goes there. Okay, so since the value that goes there is dependent on the left and the value below, we can say, let's make some variables. Int left is going to be the value to the left, and int below is going to be the value below, and then we can figure out what those are. So one reason I'm doing this way is that there's actually two possibilities. It could be that the value to the left doesn't exist, right? Or if we were doing this one, it does exist, right? And then the same thing applies below, right? If we were at this position here, the value below would not exist. But if we were like right here, then the value below does exist. So we need to cover both of those cases. Okay, so we're going to start with the value to the left. So if, and basically what we need to figure out here is if this exists, right? Okay, so let's just say this way, if the left value, sorry, left is not out of bounds, okay? And if you think about it, the left is out of bounds when the index to the left, right, which is like one less than the index we're at, is negative, right? Because the lowest index allowed is 0. So if we said if the column that we're currently at, -1, is less than 0, then we would be out of bounds, okay? But we actually want to say here, looks like our plan is to say if it's not out of bounds. So that would mean we need it to be greater than or equal to 0. Okay, and you could actually check it either way. You would just, that would affect what you put here, right? If it was out of bounds, we would set it to 0, right? If it's not out of bounds, then that means we're going to set it to the value that is actually at that position in the original array A, right? So we're going to say, that means left is going to be A at same row, but column -1, right? Set left to value at to the left. We'll say that. Okay. Okay, so same row, right? But column -1 is the column to the left. Okay, so otherwise, okay, otherwise that means left is out of bounds. Then we just set the left to 0. Okay, so then we do a similar process to deal with below. So again, we say if, and then we're going to check here if the item below is not out of bounds, then we'll set that value. Otherwise, below is out of bounds, then we set it to 0. Okay. So ultimately it comes down to what does below out of bounds mean? And so if we were to look at the rows, row 1 is below row 0, right? Row 2 is below row 1. So if we just look at the row plus 1, right? So if row plus 1, as long as that is less than num bounds, just like if row is less than num rows, then row is in bounds. Then if row plus 1 is less than num rows, then row plus 1 is in bounds. And that means that the item below is in bounds. Okay, so if that's true, then we can set below to the item in index in array A at row plus 1, right? The item below, and then same column. All right, and then otherwise we set below to 0. And then right here we can say the item in array B at that row column is going to be the sum of left and below. Okay. And And at the end here, we're going to return B. Okay, so that should do it. Okay, so we make a new array, same size as the original for every row, for every column. We look at the item to the left. If the item to the left is not out of bounds, then we set that value. We set left to the value to the left, right? And then if the row below is not out of bounds, we set below to that value. Otherwise, we're setting them to 0. Okay, this is looking pretty good. Let's just hit run and see how this goes. Then we'll just check our work here to make sure that it's doing it correctly. So let's take this example right here. We got the 2 in the upper left that came from this value. And we can see the item to the left would be out of bounds, but below would be a 2. So 2 is the correct value. Another good one to check is the bottom left here, because left and below both don't exist. So that should make 0. And sure enough, we get a 0 right there. We could check one of these ones here. Like let's say, let's see, row 1 and column 2 should add up to 13. So let's see, row 1, column 0, 1, 2. Okay, so that's this one, which the item to the left is a 9. And the item below is a 4. So that adds up to 13. That is correct. All right, it's looking pretty good. This ends the video. We've gone over simple loops, gone over loops where we had to check the row and the column, and we had to access items in 2 different arrays. We had to make an array the same size as the original. And then this one we've dealt with out of bounds situations. So I think that's everything. That completes the video. Goodbye.